Hey, what's up everybody? My name is Moss, and in this video, I'm going to demonstrate some practical ways you can use the AI assistant in Splunk Observability Cloud. For easier navigation, I've included chapter markers below, so feel free to jump straight to the topics you're interested in. The assistant will only get better with time, but today I'll show you real-world, real-time examples of what it can do right now, and how to interact with it to get the most accurate and helpful answers. We'll start by exploring how the assistant can help explain unfamiliar metrics or provide feedback by analyzing real-time contextual data, making it easier to interpret performance and identify optimization opportunities. Next, we'll cover how the AI assistant can significantly streamline the onboarding process for new hires or new users of Splunk Observability Cloud, helping them quickly understand their service architectures and how data moves between services. Finally, we'll dive into the observability as code use case, demonstrating how the AI assistant can generate scripts and automation code that interact with the Splunk Observability Cloud API. This allows you to easily create charts, dashboards, detectors, and more. So I'm currently at the homepage of Splunk Observability Cloud. To access the AI assistant, I would navigate to the top right and select this icon. Now, as an engineer, I might administrate third-party tools, and those tools might have custom metrics associated with them. And depending on the tool or the application, you might not be familiar with the metrics of that application. It could be a GitLab instance or a Redis instance. Let's take Redis as an example. I'm going to navigate to infrastructure, and then I'll navigate to data stores, and I'll scroll down to Redis. And I'll select Redis instances. And in the table, I have a single Redis instance listed. I'm going to select that instance. As an administrator of Redis, I might not be familiar with all of the metrics associated with Redis. For instance, the cache hit rate percentage. I can not only ask the assistant to explain this metric, but I can also ask it to use the contextual data associated with this instance to determine whether that metric data is good or bad. Okay, it looks like the assistant answered the query, but it did not pull the contextual data associated with this Redis instance. I'll ask the query one more time, and I'll actually specify the name of the Redis instance. Okay, and it looks like the AI assistant did identify that specific Redis instance. And it performed an accurate analysis of the cache hit rate percentage metric, showing that over the last 4 hours, the hit rate was 67%. And as you can see here, that is accurate. And it also provides an interpretation of that performance as well, which I think is very important for an administrator who might be unfamiliar with the metric, that you receive this contextual analysis of your data. And it says that this is a moderate hit rate, suggesting that there is room for optimization. So you get the interpretation, but also suggestions for optimization, which include reviewing the cache configuration, analyzing missed patterns, and application logic. It also provided relevant infrastructure attributes. And although I've already navigated to the dashboard for that Redis instance, if I hadn't, I could navigate directly to the instance using this hyperlink. It's not just experienced engineers or administrators who might need additional information or interpretation of the data in their environment. Imagine you're an engineer who's just joined the company and you're trying to understand the services in the environment and how they work together. You can utilize the AI assistant to better understand the environment and the data that's flowing between services. For instance, I might want to know what kind of data is being sent to the payment service in the online boutique environment. The assistant uses the logs to identify what's happening in the payment service, which includes charging transactions, HTTP requests and responses, of course, order confirmation, and it also identifies a retry mechanism for payment processing. And at the bottom, it provides a summary of what the payment service is doing. This kind of information is very valuable for someone who might be new to the organization and is trying to learn how services work together and their architecture. And this is a real-time representation of how those services work. It's not necessarily documentation that might be outdated. As an administrator of Splunk Observability Cloud or as a platform engineer, I might want to create automation using the Splunk Observability Cloud API. The assistant is pretty flexible with the requests that you can ask it. If you ask an unrelated, non-technical question like, "What color is the sky?" the assistant will not answer that question. However, I can still ask the assistant to write code that interacts with the Splunk Observability Cloud API. To demonstrate this, I'll ask it to write a Python script that adds my user to a team in Splunk Observability Cloud. All I need is my user ID as well as the team ID. To get my user ID, I'm going to navigate to my profile. And I'll copy it into the chat window. And then I'll navigate to the team and grab its ID. Okay, it looks like it successfully generated a Python script, so I'm going to copy this script to my clipboard. And I'm going to navigate to VS Code and paste this into a new file. Now I happen to know that this API endpoint is slightly incorrect. It's not members, it's just member. So I'm going to remove that S. And down here on line 14, we're going to replace 200 with a 204 because this endpoint will return a 204 status code if the request is successful. Now I'm not going to show my access token, and I am going to hard code it into this headers value here. And then I'll run the script. On the command line, I'll run Python add user to team. And before running it, I want to double check that I'm not currently on that team. And as you can see, I'm not listed in the team. After running the script, it did say that I was successfully added. So let's take a look back at the team page and make sure that I am listed. And now I see my name in the team page. This kind of request does lead into more of an observability as code use case, and that includes also having the AI assistant draft a signal flow program that you can insert into a chart, and you could even have it generate charts using a Python script. It can provide you with code that interacts with the API and generates charts, dashboards, detectors, and other entities in Splunk Observability Cloud. To summarize, I'd like to recap the use cases that we've demonstrated. The first use case is explaining the data that's in your environment. Like when we asked it to explain the cache hit rate for our Redis instance. Not only did it explain the metric, but it also contextualized its answer. This closely aligns with the use case of the AI assistant for new hires or people who are new to Observability Cloud and they're onboarding into the organization. The assistant can help them better understand the architecture and how data flows between services. And the final use case is really about observability as code and how the assistant can help us automate that process. It can generate simple scripts and commands that can interact with the Splunk Observability Cloud API and create various entities. You can also use it to generate signal flow code. These use cases demonstrate the flexibility and the power of the AI assistant in Splunk Observability Cloud. And it will only get better from here. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. And if you're interested in trying Splunk Observability Cloud yourself, you can navigate to this link to claim your free 14-day trial. Thanks for watching.